Okay. So we're going to be working on just one sort of level or scene for the first project in the class. And so we want to think a little bit about what a level is. And typically in a game, levels are defined spatially. So we're kind of designing a space that constitutes a level. You could have levels that work in different dimensions, but that's kind of the most typical example. And so basically all of the space that we can navigate in and everything that kind of constitutes the current stage of the game goes into our level. Sometimes we can see the entire level spatially. Sometimes we have to explore. In a 3D game, it's more likely the case that we're going to have to explore the world to see the sort of like the extents or boundaries or everything that makes up the level. But sometimes the level just looks like this. This is, Pac-Man. You can see the entire extent of the level and everything that it includes just by looking at this one layout. But when we convert this into a 3D, we're going to have a different perspective. So we're not going to be able to see everything. We're going to want to explore, or we're going to really want to encourage our player to explore the space to find everything in the level. So we want to think about how to do that. In most games, there's a sequence of levels. So a level can represent sort of like a specific space within a larger world. And usually a level has some type of puzzle or challenge that the player has to solve to advance through the levels. Levels in games also tend to increase in difficulty, so the game gets harder as you continue through it. On a sort of just basic technical level, a level is just a collection of data. So when we're looking in Godot, we can see, we can edit our level in the editor, but we can actually see everything that is made up, that makes up our level over here in the scene view. And if you look at what that looks like on the actual data side, this is an example of what the file actually looks like for a level in Godot. I think we kind of looked at this a little bit last time. But you can see it's just a text file. It's just a series of references to other scenes, scripts, images, models, all of the assets that go in. And then it just has information about where things go, if it's visible or not, all the different properties that we can set is just saved in our level data. So we use this visual editor to create the level. Theoretically, you could build the whole thing just using text or code or anything else. This is an example of a very, very early level editor. If we go to this Wikipedia article on level for video games, we can see some examples of early level editors. This is a Tide editor. And so it's kind of interesting because this does look quite similar to what we have in Godot. Obviously, Godot is 3D, or it's 2D and 3D, and it's a lot more complex. But you have basically the same setup. You have a hierarchy of what your level consists of. You have the actual visual design of the level. You have some assets of this tile set of images. And so the level editor is basically a visual way to create the level rather than having to code everything or type everything out. In early video game development, editing, these level editors were proprietary most of the time. Like the company created them and then the designers used them. And this allows for this kind of separation of different roles. So in a game design studio, you have people who specifically sort of specialize in level design or asset creation or lighting or all these different parts. And so as a video game gets more and more complex, we have different people that fulfill roles where they specialize. They have a special, technical ability. And so having these visual editors allows you to have multiple people kind of collaborating in one place. So building the tools, now we have Godot, we have Unity and Unreal, we have things that kind of exist that we can just jump into. But in early video game development, developing those tools is a big part of the process. This is a very, very early level editor from ZZT. ZZT was an early sort of shareware type game where people could actually create levels and then share them on the internet. Before like even the internet that we know, like in the 80s, I think is when it first came out. There's an article here where this comes from, so you could look into that more. Oh, 1991. So I guess it was on the internet that we think of, just barely. So yeah, they had these level editors built into the game so that users could actually build ZZT levels and publish them online. And so that was the first sort of example. Now this is, a big thing. Roblox is a huge thing. You guys probably know there's millions of people who are making Roblox levels and stuff like that. ZZT is sort of where this started. So the game becomes not just the game that the developers created, but this whole community of people who are building stuff on top of it. This is another example of that. This is a screenshot from the Stanley Parable, which is a popular video game that was built on the Half-Life game engine. So it's a good example of a game that was created with one sort of basic concept, but they made the tools available to fans, and somebody made a game that's like a completely different experience using the same basic assets and game engine. Okay. So that's how we design levels. Let's talk about some principles for when we're designing levels. So these aren't exactly rules. They're more kind of like guidelines, things to be considering. But making a level is very much like any other form of sort of storytelling or art. You want to be thinking about the user and what the user is experiencing, and how do we guide the user or the player through the level in a way that feels natural and hopefully fun. And this is especially important for video games, because if your level is hard to understand, if it's hard to get around, people are going to get frustrated trying to interact with it, as opposed to like, a movie or something like that. There's plenty of movies that might be kind of confusing, but you don't have to do anything. You just sit there and watch it. Whereas if a video game that's confusing can get frustrating very quickly. So we want to kind of encourage discovery, and we want to give the players basically enough to understand how to move around, but also encourage them to explore and look for things within the level. So guidance, this is just kind of a general term that refers to guiding the player through the mechanics of the game. Different types of games do guidance in different ways. Sometimes some games do it very explicitly, where you have a tutorial that says, if you hit this button, you're going to do this. Or this is your goal, this is what you're looking for. Some games do guidance more implicitly, meaning that they don't state that they're doing guidance, but they, encourage you to do certain things through the design of the game. So both of those things can be considered guidance. This is the first level of Mario. You guys probably recognize that. There's very, very simple guidance happening in this level. In a couple of different ways, and one is just the movement of the parts of the game. So when you start in the game, you can't go to the left; you can only go to the right, and so you're already being sort of guided in the correct direction of the flow of the game. And then you have like the enemy is coming after you, and you have to jump over stuff. Like all of these things are guidance that show you, once you get this enemy is coming towards you, so that that's something that's coming after you. You're going in the other direction. And even something just like this little wall here, that's going to tell you, well, if I run into that wall, I need to be able to do something to go over it. So it's very simple, but it implicitly communicates to the player, you can jump. And so even if you don't know what button to hit to jump, you have this sense of like, okay, jumping is something that I need to be able to do to get through this level. So guidance is very important, especially at the beginning of the game. We need to either use specific guides or implicit, game design to show the player what they should be doing. So then the next thing after guidance is obstacles and rewards. These are the two main things that happen in game design. So most objects or most components or characters or things fall into one of these two categories. So obstacles are anything in a game that prevents you from getting to your goal. Obstacles, can be lots of different types of things. It could be a wall you have to jump over. It could be an enemy that attacks you. It could be a puzzle that you have to solve. It could just be the act of exploration that you need to find something specific, so you have to walk around and figure out where that thing is. So obstacles are anything that kind of stands us in our way. Obstacles are also the thing that makes games fun. What makes a game fun is achieving and getting past challenges. So obstacles should be challenging. They shouldn't be easy. So it gives the player a sense of, if I keep playing this game, I'm gonna kind of increase my skill level and increase my understanding of the mechanics of the game. But obstacles are kind of the main thing that we're working with as game designers. We want to create a sort of goal for the player, and then we need to put things in their way to prevent them from getting to that goal. Rewards are kind of the other side of that. Rewards are things that sort of reinforce the goals of the game and kind of help the player. So sometimes, rewards, just like collecting a coin in Mario, it just kind of says, like, if you keep going, you're going to get this coin. And we kind of can place rewards throughout the game to kind of guide the player towards an obstacle or make them make choices. And rewards can also help the player. So, if you play really well, or you find a specific thing, you get a superpower, you move faster, you jump higher, things like that. So we reward the player, we make the game easier to play through those mechanics. So Sonic is a very good example of this. There's just like a big long line of rings, and you want to collect them, but there's also hidden rings and other things that kind of rewards that kind of guide you through the game. Pacing, this is just sort of the general idea that you want to give the player a series of challenges, but you don't want to just have the same thing over and over and over again. That gets really boring pretty quickly. So with pacing, we want to think about having challenges that get increasingly harder, or maybe they ramp up and then get easier and then ramp up again. So there's this kind of like dynamic. We don't want the player just kind of like doing the same thing over and over and over again. This is the water temple, which is sort of an ironic example because you're doing the same thing over and over again, but you're exploring and looking around. So a few techniques that we can use to achieve these guidelines. Signposting is related to guidance. This is just like the literal, giving instructions either through audio or visual cues, or narration or other ways to just tell the player where to go. So this is a good example of just like a literal sign that says go this way. That's signposting. Sometimes signposting is a literal sign. Sometimes it's something off in the distance that's like bouncing or glowing or doing something cool that says this is something that you want to go for. Foreshadowing is similar, but foreshadowing is a way of kind of like giving the player a sense of what they're heading towards. So this is a good example from the game The Outer Wilds, which is a game I enjoy a lot. If you haven't played it, I would definitely recommend it. This is the very first thing you see in the game, and you're already being given a lot of information and a goal. So you see this like little tower here, so of course you're going to want to climb up on that tower and see what's up there. But then you also see this planet and this kind of like glowing thing. So you don't really know what those things are, but you already have this idea like, oh, I want to go over there and see what's up with that. So we're foreshadowing this sort of location that we're going to. We're creating a explicit goal for the player, just like from the very immediate, as soon as the player wakes up in the game, they have this goal, and they also have something that gives you a sense of how you might achieve it. So once we kind of like get into the game, we want to start making things more complicated by using branching. Branching is the idea of giving the player multiple options for how to achieve a goal or make their way through a level. And this adds to the enjoyment of the game because it gives the player choice, and it gives the player, options in terms of making choices about how to achieve the goal, but also avoid obstacles or get rewards. So branching is related to bottlenecking. Bottlenecking is sort of the opposite of branching. When you have a branch and you want to bring the player from the two options or multiple options back into the main sort of like arc of your game, that's called bottlenecking. So everything has to pass through a specific point. This is one example of a chart of how you might design a game. This is from a really good article about patterns in choice-based games. And this is mostly about like interactive fiction. like choose your own adventure stories, but it really applies to all types of games, and they have a bunch of different styles of things. And you could think about each one of these charts as, individual levels or within one level. But you can think of like the starting point, then, we get to this point and we have a few options. And, in this case, no matter what option we choose, we all end up at the next point. And so this is a way of giving controlling the way that the player experiences the level or the game, giving them options, but then bottlenecking them back to a point. Then, creating a more complex set of options, but they're all bottlenecking here. Then there's an even more complex set of options. There's even a couple of places where you might sort of fail the game, and maybe you get reset to here or even to here. But eventually we all kind of end up at the same place, and then we have some good endings, we have some bad endings. So again, this could be applied to either the game as a whole or a single level. You can think about places where we give the player choices, and the choice doesn't have to be a huge choice. It could be, going to one path or another, or it could be choosing between one challenge or another. But that creates a branch, and then eventually we want the players to all end up in the same place, which is our bottleneck. So within that sort of framework, we have the idea of risk versus reward. So this is the idea that we want to encourage the player to take risks, to kind of challenge their skills. And the way we do that is by offering rewards. So you can say, do I want to take on a higher risk for a higher potential reward, or do I want to take a lower risk to have a better chance of making it through the level? This is an example of, this is from Halo. So this is like a co-op fighting game. And in this particular level, there's this very, very high level of risk versus reward. So you have to expose yourself to the other enemy, to the other team in the game. But that's the only way to sort of like make it towards the goal and to gain an advantage in the fight. So you see, you have to balance, you have to make choices between the level of risk versus the level of reward. That's another way to make a game engaging and fun for a player. Safe zone is another technique that kind of helps a player navigate and understand the level. So a really good example in just a simple game in Space Invaders, the safe zone is behind these little blocks, so you can't get attacked, but you also can't shoot at the aliens. So you can stay in the safe zone to kind of think and strategize, but then eventually the safe zone is going to get destroyed, or if you want to progress, you're going to have to leave the safe zone to kind of attack the aliens as well. So then with all of these different things, we also have this idea of layering. So layering is when we have multiple mechanics that are layered on top of each other. And this is what happens in well-designed games. You introduce one mechanic at a time. Mega Man is a really good example of this because there's lots of different mechanics in Mega Man. But the levels are designed really well, so you only really do one at a time to get introduced to one mechanic at a time, whether it's like jumping or sliding on the walls or having different attacks and different enemies. But eventually, as you go through the level, the thing that makes Mega Man really fun and challenging is that you start to have to do multiple things at the same time. So you're dealing with all of the different mechanics and different enemies and different ways of fighting, and now you have to make choices about what to do to approach any given challenge. We have one more, gating. Gating is just restricting access. So this is sort of like one specific form of creating a goal or a risk and reward system. If you have to find a key to get into a door, then you have to go look for that key. So gating is just the process of restricting access to certain parts of the level and requiring certain achievements or certain components to get to that part of the level. Here's the ice key from Banjo-Kazooie, which is a very hard key to find in that game. Okay, so this is not exhaustive. This is just a few ideas to kind of get you started thinking about building the level. So we want to start, guiding the player through what different kind of components exist in the level and what they can do. But then we want to start giving them some challenges, start giving them some choices, and start building on the complexity. There's a bunch of links here to some different places with different level design ideas. So if you want to kind of get into more depth, this is just kind of like an essay about level design with different lessons. This is a really good GDC talk by Robert Yang, who's a game designer who teaches at the NYU Game Center, I think. At least he used to, if he doesn't anymore. But anyway, it's a really good talk just about level design, and a lot of it has like a lot of different sort of like layers to what he's talking about in terms of game mechanics, and also representation, and all sorts of stuff in there. Some more. This is like a devlog with some level design principles. This is an ad, obviously. And so this is a developer sort of like demonstrating and showing the concepts he's working on as he's developing the game. So it's kind of an interesting example. Some more videos on just level design techniques and philosophy. This looks like maybe this link. Wait, what is this? I think this link is not the right one. I'll have to look up an archive of this link. I'll do that later. But this is, yeah, more level design patterns in 2D games. This is a whole website that's just about level design. So it's just like a lot of different articles about level design and different. They have like a whole database, yeah, of just like tons of different stuff. So there's a lot of good stuff in here. A good place to just find articles on specific things. You can search through here and then look at, you know, lots of different resources. This is a similar website, World of Level Design. Again, just a lot of different articles, different concepts. You know, they have a whole bunch of different stuff in here. This link also doesn't work. So it looks like the game developer, I remember when they changed their site design, but it looks like they broke all their links more recently. So I'll fix those links, but this is, an article about procedural level generation, which is a little bit more advanced. You have to do some coding to do that, but I find it very interesting. That's what I use in a lot of my projects. Anyway, those are some resources. Obviously, there's a lot more stuff out there, but this is just hopefully some ideas to get you started with your level as we kind of like work on our first project. We just want to think about ways. First of all, how do we get the player to like sort of want to explore our level through challenges and through different visual cues and stuff like that. And so that should be the goal for our first level. We don't have a lot to work with. We're just kind of getting started simply. But think about ways, even with just the basic stuff that we have, how can we encourage the player to explore the space of our level, to learn the challenges of the level, and engage with sort of the concept of what you're building. All right.